Commercial Distributed Control Systems Part 1. We are going to discuss the elements of commercial distributed control systems, namely data highway, that is field bus, supervisory or host computers, front-end computer and upper-level computers. This diagram shows the elements of a commercial distributed control system in a nutshell. Here one can see the front-end computers connected with the process on one end and to the field bus on the other end. Then we are having the data highway with which the upper level computers are connected. One can see the host computer which is in communication with the main computer. Request. It is hoped that this session is going to be useful to you. Please press like. Please subscribe. A schematic of the DCS network is shown in the figure. Basically, various parts of the plant processes and several parts of the DCS network elements are connected to each other via the data highway or field bus. Although the figure shows one data highway, in practice there could be several levels of data highways. A large number of local data acquisition, video display and computers can be found distributed around the plant. They all communicate to each other through the data highway. These distributed elements may vary in their responsibilities. For example, those closest to the process handle high raw data traffic to the local computers, while those farther away from the process deal only with process data but for a wider audience. The data highway is thus the backbone for the DCS system. It provides information to the multi-displays on various operator-controlled panels. It sends new data and retrieves historical data from archival storage and serves as a data link between the main control computer and other parts of the network. On the top of the hierarchy, a supervisory or host computer is set. The host computer is responsible for performing many higher level functions. These could include optimization of the process operation over varying time horizons, that is days, weeks or months. The host computer may carry out special control procedures such as plant startup or product grade transition and providing feedback on economic performance. A DCS is then a powerful tool for any large commercial plant. The engineer or operator can immediately utilize such a system to access a large amount of current information from the data highway, see trends of past process conditions by calling archival data storage, readily install new online measurements together with local computers for data acquisition, and then use the new data immediately for controlling all loops of the process. Alternate quickly among standard control strategies and readjust controller parameters in software. An engineer can use the flexibility of the framework to implement his latest controller design ideas on the host computer or on the main control computer. In the common DCS architecture, the microcomputer attached to the process are known as front-end computers and are usually less sophisticated equipment employed for low-level functions. Typically, front-end computers would acquire process data from the measuring devices and convert them to standard engineering units. Upper level computers. The result at this level are passed upward to the larger computers that are responsible for more complex operations. These upper level computers can be programmed to perform more advanced calculations. Next lecture. The name of the next lecture is Commercial Distributed Control Systems Part 2. In the next lecture, description of the DCS elements shall be discussed. It is hoped that this session was useful to you. Please press like. Please subscribe.